Thank you. Thank you. Good morning. Welcome everyone here in Las Vegas and everyone around the world following our presentation online. So this is the ARCHICAD 23 official, launch or release presentation. So we are first time showing you ARCHICAD 23 live. But next to ARCHICAD 23, there is going to be lots of other unveilings today. So for the next couple of 75 minutes, we have like a whole series of presentations. So let's dive deep in. So any great product development starts with the fine balance in between features, functionality, new capabilities, and making the existing capabilities better functioning, so like performance. To make my point, let me borrow an example from our good friends at Apple. So at the last iPhone update, the camera feature got a huge boost both in functionality. So adjustable depth control is something that in the previous iPhone you couldn't do. It's a new capability. As well as performance. So it's much better now taking pictures in low light conditions like, at night. You could take pictures before at night, but it's not much better now. So much better performance. With ARCHICAD 23 and the previous versions, we try and keep this fine balance in between these two areas. And for the new release, we have these three main focus areas, along which I will walk you through this morning. Let's start with modeling, which is, I suppose, at the very core of BIM. So you might wonder if after 30 years of development, there's anything new to add as a capability to the BIM tools modeling. To a little surprise, I think there is still, and it's at the core of actually the buildings as well. So the whole architecture started with beams and columns. And this is so fundamental to our profession that any architecture student is first introduced to the architecture proportions at school via learning about, these columns module system. But evolution hasn't started, so still going on. So there is a big trend going on for quite some time in modern era, which makes us enhance and introduce new capabilities to our beam and column functionality. So what I'm talking about is buildings are less and less being constructed on site as opposed to created in factories and assembled on site. And as I said, it's not a very recent thing, so it started like 50 plus years ago with some dead ends. This is an image from Budapest. We have these panel buildings. But I think the direction the industry is taking now is taking parts of buildings and fabricate them in factories, deliver to the sites, and then assemble there. So there are dedicated software solutions to support the manufacturing, but there is no very specific dedicated BIM tool to support the design of these structures. So this is what we would like to show you in ARCHICAD 23 now. So let me invite my colleague Ákos Karockai, who is happy to show you the new revamped beam and column tool in ARCHICAD.
Thank you, Ákos. Thank you, Ákos. Thank you, Ákos. I'm on. So, welcome everyone. And as Ákos mentioned, we renewed the beam and column tools in ARCHICAD 23. And in the next few minutes, I would like to show you these enhancements through three different structural types. Precast concrete, steel and glued laminated timber. And we're going to have one extra there. So, let's see the first example. Let's say you have to design an industrial building where the structure is proposed to be precast concrete by the structural engineer. And previously, how you could do that? Let's take a look at a column and beam joint of such a precast system. So this is what I would like to model in ARCHICAD, right? Previously, how you could do that? By using Morse, using custom GDL solutions, which was possible, but it was quite cumbersome and time-consuming. And at the same time, getting out documentation, scheduling of such elements was quite difficult. But in ARCHICAD 23, with a dedicated solution, we can do it much easier. So let's try and recreate the previous connection that I just showed you. And one of the biggest enhancements that we introduced to beams and columns is that now we can use multiple segments within one element, which will make you possible to create more detailed geometries. So if we take a look at this, I don't have a proper support for my beams, so by adding a couple of simple segments, I can edit it on a segment level and give it a proper support. Right, so right now I have a simple cantilevered support, but based on the input from the structural engineer, I would like to create a corbel type support. And doing that, it's possible to, we introduce a new functionality to make it possible, and these are the tapered segments, which meaning that the dimensions of the cross sections can alter throughout the axis length of the column or the beam. So right now we can very quickly create such corbel type supports for the beams. Now, so far this is all right, but let's take a look at the beam and make it a proper ending as well. Similar to the columns, I can add segments to it by clicking on the reference line. And right now, as you can see, it looks correct, but this is only a result of the priority-based connections at the support. So since we are using parametric complex profiles, I can get rid of the girder depth or just reduce it. And since I do not need a stronger support throughout the beam, I can make it a little bit thinner on the top. But right now, I have two different versions of the same parametric complex profile on these two parts. Now, how could I bridge the gap? By combining the tapered segment capability with parametric complex profiles, I can get a real smooth transition between these two segments, allowing me to create such connections. Now using these multi-segmented beams and columns, we can very quickly, in about 20-30 minutes, we can model such a huge industrial building which is structurally correct. So, such as the roof supporting structure beams with tapered segments and custom endings. Or for example, we can take a look at the precast pocket footing of the columns, which is just a simple two-segmented column basically. Alright, but besides the proper structurally correct 3D representation and modeling of such elements, we also have to take a look at the 2D documentation in all projected views. So let's take a look at the floor plan representation and the foundation drawings of this building. And now in ARCHICAD 23 we introduced the cover fill functionality for both beams and columns. So now you can have a proper floor plan representation in all projected views. But we went one step further as well, and now we can display hidden elements underneath slabs. Completely correct. So let's just cut a hole into my slabs here. And as you can see, we have within one element, wherever the element is hidden, we can display it with dashed lines. Wherever it is visible, it is displayed with solid lines. Now what do you think will happen if I adjust only this one edge of the slab? Can the representation follow? Well, sure it can. And I believe this is a very nice example on how much emphasis we put on making ARCHICAD right to the finest detail. All right. In the next example, in the second example, let's say you have to design a sports hall, a handball court to be specific, where the functional requirements are quite simple. You have to put a roof and some walls above the court. And previously you could do this, but let's also add a little bit of twist to this building. And instead of an orthogonal grid, let's make it a skewed and distorted grid. Now, in this case, as you can see, each and every frame is slightly bit different than the other. Previously, it was quite difficult to model this, but in ARCHICAD 23, we introduced a new two-point placement method for both the beams and columns. So now you can connect any 2 point in space in 3D very easily and very quickly. So in just a couple of seconds, I can model one of my frames, and the same goes for beams as well. And in this case, I'm using multi-segmented beams as well, with tapered segments giving me a correct structural representation of such frames. And there's one more thing, that we introduced custom end cut angles for these columns and beams, so you can have nice and clean connections for your beam column connections, such as this one. Now let's take a look at on the inside when the building is done. And similarly to the frames, you can very quickly and very easily model the cross bracing or the purlins of the roof structure, allowing you to work correctly and accurately and still focus on the design. All right, so far we've been dealing with orthogonal or linear structures. So let's take a look at something different. I have a water sports arena here, and I would like to create the roof structure of this building using long span glued laminated timber. Now previously we could create curved beams in ARCHICAD, but only in a horizontal plane. Now it is possible to curve beams in a vertical plane, allowing you to model such buildings. So I just simply grab the reference line of this beam, and I can create these vertically curved structures. Again, let's take a look at how it looks from the inside. I believe it's quite impressive, isn't it? But where else would we use vertically curved beams? For example, in case of historical projects and renovations. So we've took the tool for a ride, and we tried to see how it performs with by creating this church building. And as you can see, we've modeled the columns with multi-segmented columns using parametric complex profiles. The vertical arches are modeled with beams, and even the ribs of the vaults are created with the brand new and renewed ARCHICAD 23 beams and columns. So I hope in the past few minutes I could show you how powerful the new tools will be, and with that you will be able to create such projects and much more, I believe. Thank you, and back to Ákos.
Thank you, Ákos. So let's continue with another mission critical core functionality or functional area for BIM, which is coordination, bringing together the work of larger teams inside architecture. So how an architecture team coordinates their work. So they have project origin, obviously, in the BIM database, and they organize their work around stories. Once the structural engineer comes into picture, obviously the global origin still works, but with the structural engineer, you speak along the lines of a structural grid. Then the whole thing gets tricky when the MEP engineer comes into picture. So at that time, you have to go down to the element level, and you coordinate your work with a peculiar type of element, which is an anti-element, I would say, the void, the mechanical void. How you do that is called a special workflow provision for voids. So the mechanical engineer figures out where these structures need to be broken through, and then sends provisions for void to the structural engineer and the architect. And in a typical building, there are hundreds of such provisional for voids, and this is not a very static thing. So as the design evolves, these matching points need to be adjusted, modified, and kept up to date. So there is a very peculiar workflow that needs to be supported on the BIM level with proper documentation and listing and scheduling, which is not so easy. So to avoid mistakes like that, your revision cloud cast in concrete, you have to provide BIM level information about the places of the holes, and not just, so solid element operation is not enough, because the clearance of these voids is bigger than the actual element, and also you need to have the proper documentation. So without talking further about the theory, let me invite Szabolcs on stage who can show this one in life for you.
Thank you, Ákos. Thank you, Ákos. Hello, everyone. So as you heard, openings or structural openings, or in other words, mechanical voids, must be handled by all disciplines in the AEC industry. So we needed a true BIM workflow. And in order to cover this, we designed this new tool, the new opening tool. And let's see how this tool works. So the opening tool was created with the IFC definition in mind, meaning that an opening belongs to one element, but it can be linked to multiple elements at the same time. So see, this is one opening cutting through all layers at once. What else can we do with this particular opening? An opening can be aligned with the surface, or they can cut through elements vertically and horizontally. And they can also have a custom angle, which gives us flexibility in geometry and design. And also, last but not least, it also can cut through multiple element types at the same time. So the same element is cutting through multiple element types. Okay, just remember that there are two basic types of openings, recesses or niches and voids. Now both of them can be modeled with the same tool. And it's not only that they are 3D geometry is correct, they can be dimensioned, and we can also place labels on them associatively, for example, pointing at their classification, at their data, at their height information and such. And it's not only labels that it's capable of, it's not only their documentation, it's of course scheduling. So these openings can be scheduled one by one with the linked elements and with their thickness, height, and width values. Okay, so this was the basic tool demo. Let's see how this tool can be used in practice. So the first example I'm going to show you is from the early design stage, when, for example, the architects need to know the location, needs to plan the location of the vertical voids penetrating through the slabs, for example, for the elevator slabs or elevator shafts or the mechanical ductworks. Now, how would he do this before? Probably placed a slab hole into the element, and then we had to place a 2D symbol on the floor plan. Now this can be done in one step with the new tool. I just select one extra favorite, and as you see, I can place an opening with one step with the correct 2D representation. Now let's switch to 3D and see how this looks, because it's not only one view, it's not only the 2D where it's represented. Of course, it's this 3D body. I can select this element, and as I told you, since it can penetrate through multiple structures at the same time, I can easily add all slabs on all stories, and then this one element can cut through all of my stories at once, and they can be moved together as well. Now let's try a different approach, by not planning this on the floor plan, but by using editing aid morph bodies to cut through all my structures. And for this, I'm using now morph bodies. What could I do with these? I can select these elements, and to create openings based on these morph bodies, we have implemented a new editing palette. It's called Create Openings from Selection. And then I have a little palette over here which can be used to create these openings. Just to explain a little bit how this works, we can choose the shape of the opening, we can give an offset, we can add a clearance if the engineer or the structural or the mechanical engineer has requested, and we have a lot of other controls. Now in this case, since I use these morph bodies at editing aid, I do not need to keep these operator bodies, but merging these nearby openings is probably a good idea in order to create one opening that penetrates through all structures. So what happens if I press Create Openings? All of them were created at once, and I can select them and see, as a reminder, these are one element cutting through all slabs at the same time. So this was one example, and let me show you another use case, which is from later design stages, when model coordination becomes more and more frequent, and we need to exchange, according to the previous workflows, we need to exchange with the MEP and with the structural engineers more. Now, Ákos mentioned this name. It's called provision for void workflows. To explain this a little bit better, let me switch to Solibri to show you how this works. And I specifically thank our Swiss partner and clients for providing us with this model. They have worked on this in the near past. So, what does this look like? We have an architectural model, but what we also have, we have a structural model. We have a structural model and an MEP model in the same IFC file. So, and at this design stage, the MEP engineer has located important points where their elements pass through load-bearing structures. And it's very important to know where these points are. And they need to highlight these points for us in order to be able to create the required openings in our architecture model as well. How could I locate these elements? How could I locate these elements and where they are? They highlight these points by sending us provision for void geometries. And with the help of these editing bodies, we can create our openings in our own file based on the MEP model. So, switching back to ARCHICAD, I'm just going to switch one view. So how do we receive these files? These provision for void geometries will be the part of the imported or hot-linked MEP IFC model, but not part of the MEP structure. They will be this editing aid for us, which we can use to create the openings. These can cut through slabs, for example, but usually most of these openings would be, we need to place most of these openings into the walls. And imagine how many of them are in one building. This isn't a too big project, and even here I have hundreds, maybe 150 openings that need to be placed at once. How can I create all openings in one run? Now since it's an IFC model and since this is a coordinated IFC model, these elements have a classification called provision for voids. So I can select their geometry based on their classification and select them in one go. And just to be a little bit more exact, I'm going to zoom in on a detailed example. So over here, you see all these openings on the ground floor, and we need to create them. In one go. I'm going to use the same editing palette that I have used before. In this case, I will keep my original elements because they are not in my domain, and I need to keep them around. But merging doesn't make too much sense at the moment. However, since the MEP engineer can request a clearance around these voids, I can add an extra 10 millimeter clearance around these opening bodies. So what happens if I create the openings? They are created at the moment. Let me just turn off these layers for you to be able to see it, and I'm going to change the graphical override. So see, now all these openings were created in one go in the 3D environment, but it's not only the 3D that we need to cover. As Ákos mentioned, one of the most important things is to document these on the floor plan. So I will switch quickly to the floor plan view, and you will be able to see that it's not only the 3D body that we have generated with this command, it's also their floor plan representation in the walls with the correct 2D symbol. And luckily, since we need to apply to different graphical standards in each country, ARCHICAD 23 library comes with a set of 2D symbols that you can use, since the opening element has a built-in functionality to cleverly use these GDN symbols as for their cut and uncut views. So you can choose from a number of settings. All right, so hopefully I could show you how this new tool works and how you can utilize their capabilities. It's not only 3D, and it's not only 2D where they can work, they can help in coordination workflows and their interdisciplinary communication as well. Ákos, thank you. And thank you all.
Thank you, Szabolcs. So let's turn our attention to the right side now, and let's have a little fun. When you talk about performance, cars come to mind all the time to make parallels. So I brought here for you 2 cars, and let's play a little game. On the top, it's a Ferrari, a very fine sports car. That's the latest model, called 812 Superfast, nomen est omen, as the Latins say. And at the bottom, it's the Tesla Model S. So my first question is, which car do you think is faster? And when we measure, fastness, we measure it in acceleration because, top speed is artificially limited these days. So let's talk about acceleration. Which car wins? Remember, the name of the top car is Superfast, and it's a Ferrari. Okay, anyway, you figured it good. Both are extremely fast, but the Tesla is a little faster. So my next question is, which car would you like to drive more? In other words, which car is more fun to drive? I suppose the Ferrari. And the third question is why? It's because the Ferrari was designed to feel fast, not necessarily just run fast. It's a very fast car, but it was designed with the driver in mind. And I think this makes a huge difference. So the red color, the design, the big exhausts, and the sound of it, like that, consciously engineered. So if I want to make a conclusion, then the Tesla wins in sheer performance, but the Ferrari bumps your heart a little more. And this is not just about fun. It's more like the philosophy how you design a product. So let me switch to a total different product type, which is elevators. There are all sorts of conscious design decisions in elevators to make you feel better during your ride. I'm not sure if you know the ultimate purpose of mirrors in elevators, but it's to make you feel comfortable and feel the travel time shorter. Same thing with the close button. You want to be in control. That's a human nature thing. And there's no need for the close button because the door closes anyway. But if you can initiate the action, then you feel in control. And I'm not sure if you knew it, but here in North America, United States, rumor says that 80% of the close buttons are non-functional. They are just for your psyche. But this is, more like for preemptive things. But there is some other examples closer to our industry where it's a more proactive thing. So when you work with your laptop and you finish work, you close the lid. What does a normal computer do, a normal laptop do? It was a direct user command, wants to close me, so let's shut down. But in many cases, you are not 100% sure if that very last email went out from your outbox. So you open back up. In the Mac, it's still running there, waiting for you, because the engineers at Apple know this behavior of the human nature. So, and great many other things, examples from this domain. My point is that in BIM software and ARCHICAD in particular, this perceived performance in combination with very high performing technology underneath provides you best-in-class user experience. And that's what we want to enhance big time in ARCHICAD 23. And to show you that, let me invite Annika on stage.
Thank you, Akos. Hello, everyone. So, Akos emphasized how important performance is from the experience point of view. Let me also emphasize another point of view that I consider as important as the experience itself, and this is business, and basically this is where we are here. And why it is important is because performance is also about actions that we repeat all over and over again in our daily work, but we are not paid for, like opening a file. Is there anyone who is paid for opening a file? Not really, right? You're paid for designing the building, right? So that's it, but we've got to do that anyway. So in this version of ARCHICAD, we focused on those things in the performance improvements which takes a lot of time, takes a lot of attention, but they're not part of your core business. So just let's imagine that you return to your office. It's the morning, people come in, they fire up the computers and the coffee machine in somewhat order, and you're about to start working. So what is the thing mostly people do? They just like to continue the project they worked before in the previous day. So there is a file, what they want to open. So let's open a project. So in the previous versions of ARCHICAD, what happened at the opening process is that ARCHICAD started asking questions and prompting and interrupting the opening process and requiring user interaction on the spot about license information, missing hot links, maybe library parts, some outdated drawings, and things that are not really relevant to sort out in the opening process. Actually, it doesn't even let me to finish my sentence if you recognize. So that's it. Welcome to ARCHICAD 23. All right, so this is one thing when we explicitly know what project to open, but there is another case when we're uncertain about that. So let's see an example on what happens if we don't know exactly what project to open. And start ARCHICAD again to see how startup works from now on. In ARCHICAD 23, we've got a brand new startup dialog box with a lot of additional features. If we don't know the name exactly, we can use the search field to type something. And this search field does not only searches in the file names, but also in the project info. If you're more visual kind, you can also use the preview pictures. Now, these preview pictures are not just static images, but they play a slideshow about the open tab pages of your project. So another easy way to choose your project you're going to continue with. And the good news is that while we're spending our time here to pick the project, in the background, the computer continues to load the different parts of the software into the memory. So by the time we click on anything here, it will be up and running to open our project. We also have a nice list view, and the last case I'd like to emphasize here is what if I'd like to open multiple projects in one run. So from now on, it is also possible. You can have multi-selection, and if you click the open button, it will start as many ARCHICAD instances as necessary to open all projects selected here. Okay, so let's quit this for now and return to our real project. That is a nice residential building from AGP Architects, built in Southampton, UK. This is an award-winning residential tower project. Special thanks to the company to let us use it as a demonstration. So this is my project, but before we start actually design, we have to think about where all these previous questions go. And for those people who are really in charge of sorting out the questions, like be managers or project coordinators, we designed a center interface that is called the Action Center. So this interface collects all diagnostic data from now on, and these people can find those. There is a direct access to those dialog boxes where actually the problems can be solved. And it is also color-coded, so once a problem is solved, the color will instantly change in the Action Center view. All right, so the second challenge to work effectively is finding the right way we like to develop our model. And in case of such a complex project, it sometimes is a challenge because we might have many different tab pages open and it is hard to distinguish which is which, right? So for example, here I have many views open, but because the beginning of the view name is the same, I have no idea what is what. So we could go with the traditional try and error way and just starting open it, but it would require a lot of time, and we all know time is money. So instead, from ARCHICAD 23, what you can do, you can just simply hover your cursor over the preview to show its content. So whichever view I like to go, all I need to do, I hover my cursor over the view, and as you can see, it immediately shows you the picture, how it looked like before I left this page. All right, so now our project is healthy, our issues are solved. Now we can find the view easily. That is great. So all we need to do now is design and develop our model. Finally, great. So let's talk about view updates now, because this is also a quite challenging thing. We model something, so how long we've got to wait until all the relevant views get updated. Let's do a little experiment. So we've got this flow plan here, and we also have a 3D. So now I'm going to do some modeling. Of course, just for the sake of the demo, I'm going to place some walls on the top of this roof here. So what is going to happen if I switch back to the flow plan? Is it going to redraw the entire thing just for the sake of these 3 walls? Let's try. Of course not. So the view is there instantly, and in a fraction of seconds, my new walls appear. So in this demo, we could just show you these examples on how we improve the performance of ARCHICAD 23, but there are many other areas in the software when you can meet these enhancements. So I wish you to try it with your own workflow and find your favorites. Thank you.
Thank you, Annika. We are not done yet with performance. So next to ARCHICAD, we are working very hard on improving the performance of our BIM Cloud version coming out with ARCHICAD 23 as well. Much larger, project environment, many more files on the same BIM Cloud, as well as much faster opening of BIM Cloud projects. But let me talk a little bit about still not the cloud, the local performance. And I think you agree with me that next to speed, also size belongs to the realm of performance. So what about project size? On personal computers, it's relatively easy to boost performance by boosting the hardware itself. So adding RAM helps you to some extent, so that's a scalable thing. But in the mobile platform, the hardware is set, so you cannot just add memory. So it's been a huge bottleneck up until now to display large, actual, real, detailed BIM projects on mobile devices. But this is the kind of challenge or problem Graphisoft has always been very good at. Developing software, high-performing software to low-spec hardware. So let's see what our new latest and greatest BIMX engine can do on low-spec devices. For that, let me invite Belinda on stage. Belinda?
Hello, everyone. Thank you. Thank you, Akash. All right. I think we all know the problem that many times. Sorry, but you guys need to switch to the iPad. Please. Yeah, there we go. So, I think we all know the problem that many times extreme, large, complex, high-poly models are quite difficult to open on weak mobile and tablet devices. And to be more precise, this is usually not the fault of the app, but of the insufficient memory inside the hardware itself. But with our next gen BIMX Lab engine technology, we have found the solution to the problem. And I think the best way to show it to you guys is by opening up both applications to give you a direct comparison of both engines. And I'm going to demonstrate the difference to you by first opening up a really, really small, simple, light model, the BIMX Demo Hyper model. And now I just need to make sure that I tap both buttons at the same time. So ready? 3, 2, 1, go. Yep, all right, you see? Wait, guys, wait. It's gonna get better. So even though this model is quite small, the current engine was still slower in loading it than the new engine. And this model has around about 100,000 polygons, which is really not that much. So that's why let's step up the game. Let's go next level. I'm gonna open up a medium-sized model, the Casa Magallanes. This one has 1 million polygons, so 10 times more than the previous one. Okay, so 3, 2, 1, go. Yeah, so you see that while the current engine still gives you this progress bar to look at, the new engine has already loaded the model incrementally into the scene. Yeah, so very nice, very fast. I think we're on the right track here. Because now, let's go big. And by big, I mean very, very big, because with our next model here, guys, we are trying to deal with 15 million polygons. And believe you me, this is quite a big fish in the world of 3D models. So let's see which engine catches the fish faster. 3, 2, 1, go. So as I said, 50 million polygons. So in the meantime, let me tell you a little bit about the project. So it was designed by our client ARCHICAD in the Ukraine. It's a residential project, 125 square meters of area. It was finished in 2018. And again, we're dealing with 15 million polygons, and I guess that's why our current BIMX Pro engine just crashed. I mean, you know, Graphisoft usually doesn't like to kill their own products, certainly not on stage in Vegas. But this time, it's looking good for us. So let me show you what just happened. So the reason why our current BIMX Pro engine just crashed was because it just simply couldn't get enough memory on this iOS device. This is how iOS works, but how does our new engine work? Let me open this up. So the way we do it is we change the technology in a way that we don't even try to load the whole model into the memory. Nope, we are streaming it. So you see, if you pay attention, if I zoom and if I navigate, you see how it incrementally builds up. This process is called geometry streaming or memory streaming. So that it means that while I navigate, while I pan, while I zoom and do my things in BIMX, it only loads those parts of the model into the scene or into the memory which are just currently visible to me. So whatever is besides me or behind me is not yet loaded into the memory. And this way we can save on system memory, we can decrease the file size, increase performance, and so on. And I think with this technology, we found a pretty good solution in dealing with these heavy polygon models, and for both older and newer devices, because this little fellow here is around about 3 years old and has just 2 gigabytes of memory. So we're not showing this here on the latest and newest tablet, no. So with this technology, you can now open up any kind of model size on any kind of mobile device. Cool. Let me show you another cool thing about BIMX. So just to give you a little bit of context, so far, if you want to get access to the BIMX hypermodel, you first had to download the model, get the BIMX app, and so on and so forth. This worked pretty well for a lot of people, but if you want to quickly and easily share it with your client, you don't want to really give him long instructions on how and where to download the model, how to, where to get the app from, how to update the app. No, you don't want to do that. So what's the solution? We think the best solution is a platform-independent BIMX 3D viewer. So let me introduce to you our new BIMX web viewer. And this means no need anymore to download apps or to update the apps. Nope, you just have a link with which you can share the model with, and then it's right here up and running in your preferred browser. And just like in the BIMX mobile app, you have the 3D model viewer on the right and the hypermodel index on the left. And here you can, access all your 2D documentation. You can slide through the whole 2D documentation sets. You can also access other related drawings right here. And here you have the choice. Do you want to open it up in 2D or 3D? Of course, let's go with 3D. And voila, you see, in your browser, it switches automatically to the drawing. And a pretty cool feature is also that we kept this feature of using the drawing as a cutting plane. Now let me just turn this off and hide it here. Let's go back to the home view. Okay, this is our beautiful Graphisoft headquarters in Budapest. And now, with your mouse and the keyboard, as you're used to, you can pan, zoom, navigate freely throughout the model. You can explore the building in a bird's eye perspective. But if you don't feel like a bird and you rather want to walk, no problem, just go ahead, activate the walk mode, which activates the gravity. And here again, use the mouse and the keyboard to navigate. We also have an on-screen joystick, obviously for touchscreen devices such as the Microsoft Surface, which obviously doesn't have a keyboard. Okay, now let's enter the HQ building. And before I show you around, let me switch to my new friend here. So, because now to ease up your navigation experience, you can use any kind of external controller, just like this Xbox controller here. Yeah, because just like me, I guess you're all secretly gamers and you know how to use this thing. If not, it's high time. So, because look, it's so much smoother, much nicer. Oh yeah, and if you want, you can have a try this later in the visualization booth. So, now I can show you around. On the left, we have a beautiful, impressive piece of art dominating the lobby area. And on the right, we have a nice, new, hip, redesigned cafe area where we usually sit and sip on our Americanos and espressos and cappuccinos, whatever. Whatever your heart desires, you are more than welcome to pay us a visit. So maybe now I can even show you where I sit. And since I'm Superwoman now, I don't need to take the stairs. I'll just quickly jump up here. And let's enter the product manager cave. Here we have my colleagues sitting. And this is right here. This is where I sit. And guys, this is a pretty cool spot because, right behind me is a wall, meaning that no one can see that sometimes, just sometimes, instead of working, I might play some Fortnite here and there, just for research purposes, because, my boss sits right here next to me and he doesn't know. Well, now he knows. Sorry, Peter. We can talk about this later. All right, let's check out Akos's office. So when Akos is not traveling around the world or in meetings, he's really, really busy and working really hard. Oh, sorry, Akos, I guess the Fortnite craze is getting to everyone here lately. Anyway, guys, I think you got the message that the point is with this new BIMX WebGL technology, you can now explore the building from your browser, really easy, really simply, shared via link, use any kind of navigation tool, yeah, and feel pretty cool in front of your client using this little fellow here. Thank you.
Thank you, Belinda. So, we have covered modeling, coordination, and performance, but there is still more to come. So, we haven't talked about design yet and visualization. In these areas, Graphisoft decided to partner with the best in the world technology partners, developers. So let's share with you what's coming with ARCHICAD 23. So in the realm of design, we have shown you a number of times this diagram explaining, the conceptual problem that the conceptual design of the buildings is very much cut off or broken from the BIM workflow. And our proposed solution is to use and integrate algorithmic design solutions into the BIM workflow, making it a much more dynamic and vivid workflow. To do that, we have been a very amicable, very good partnership with Robert McNeil and Associates. And we have been working on integrating the two solutions, Grasshopper Rhino with ARCHICAD. And our, strategy here is providing access for the algorithms on the Grasshopper side as deep as possible in the BIM model database. To do that, we have started to develop a workflow we call deconstruct, which means deconstructing everything in the model database and allowing access for the algorithms to take as a reference, manipulate, optimize, and give back to the BIM model. So we have shown you first examples last year. Now we have made a huge step ahead, further improving our deconstruct workflow. To show you that, let me invite Ákos back to on stage. Ákos?
Thank you, Ákos. So, as you know, Graphisoft has been a pioneer in the past few years connecting algorithmic design with BIM by creating a deep link between the inner logic of Grasshopper and Rhino and the building logic of ARCHICAD. And this year, in the latest version of the Rhino Grasshopper ARCHICAD Live Connection, we went one step further and to allow you to access the surface geometry of any ARCHICAD BIM element. Now, what is it good for? On one hand, you can use this surface geometry as an input in Grasshopper and Rhino to generate additional BIM elements, or two, or on the other side, you can use this surface information to analyze and optimize the BIM model using the vast ecosystem of the Rhino Grasshopper platform. So let's see an example for the first one. In this example, we are designing and we are working on a tennis stadium that is in the early design phase, where we are still experimenting with the building envelope. And what I have in mind is a double layer facade consisting of an internal curtain wall and an external perforated metal shell. And I would like to use Rhino and Grasshopper to generate a supporting structure between the two layers. And I would like to do this using the live connection to be able to experiment and work with the building envelope in the context of the BIM model. So let's see how it goes. I can very simply reference the ARCHICAD shell into Rhino and Grasshopper. And let me show you the structure that I have in mind between the two. So it's like it's consisting of beams and columns. So let's just bring those in to ARCHICAD. And very quickly, as you can see, they appeared. But as I mentioned, we are in the early design phase, which means that the building design goes through a lot of changes. For example, I would like to bulge and curve the profile of the external shell of the ARCHICAD shell here. Something like this. So now I change the surface geometry of the ARCHICAD element, And by sending the changes to Rhino and Grasshopper, the code recalculates the structure between them, and it bulges it according to the surface geometry. And this allows us and allows you to discover more different design options and experiment more with the building envelope and try out different variations, basically. All right, but another advantage of the Rhino Grasshopper platform is its amazing ecosystem of plugins. For example, for environmental analysis and optimization. So in the next example, I have a nice little restaurant building on this hillside, and I would like to perform a sunlight hour analysis on it. And since with the latest version of the live connection, we can extract the surface geometry of the facade that later on we can analyze, and in this case I'm going to use the Ladybug add-on of Grasshopper. So I can extract the windows, I can extract the roof geometry, and based on that I can run a sunlight analysis. So let me just show you the result of that. And as you can see in the bottom left corner, my facade is quite exposed to the sun. The red areas are more exposed, the blue areas are a little bit more shaded thanks to the roof. So what can we do to make it a better performing building? Obviously we have to create some kind of shading system. And what I have in mind is a shading system that is consisting of vertical frames and is waving along the building facade. And for that, a quite obvious choice would be to use ARCHICAD's parametric complex profiles, an innovation that we introduced last year. So I would like to use this profile, but multiple versions of it. And in the latest version, now we can control these offset modifiers from Grasshopper based on some parameters or some curves. So let's just do that. Let's bring in those geometries. And let's see how it affects the performance of our building. And once the geometry is loaded into ARCHICAD, as you can see, it's nicely waving through my facade. But again, since you might want to try different design variations, you can play along with some Rhino curves. And I believe this is a little bit too much bulged in here, so let's make it a little bit more subtle so that the guests from the restaurant can enjoy the view. And as you can see, by just adjusting a little bit of a curve, it opened up the facade. So let's see how my analysis looks like after applying this shading system. As you can see, this is the result after the shading system was applied, and this is before that. And this is created by referencing the ARCHICAD beam surface geometry into Grasshopper and just running an analysis very quickly. So as you can see, we could seriously and significantly improve the performance of the building. And I hope that you can see that using the new deconstruct functionalities and using the parametric complex profiles combined with Grasshopper, you can have much more time for design and have better performing buildings. So thank you very much.
Thank you, Ákos. Thank you. And I would like to ask you to give your hands to Bob McNeil as well, who is sitting with us this morning in this room. So thanks, Bob, for providing us with this amazing technology. Okay, next up, visualization. What is architecture visualization? Simply put, it's sales. So you are selling your design to the client. And architecture visualization has been through a long way from, hand-drawn sketches and different types of 3D visualizations. But I think technologies get to a certain stage we call tipping point. And I believe in 3D visualization, we are at the brink of such a tipping point moment, because technology reached a certain stage where things will revolutionarily change our workflows, how we handle things. And we are in a lucky position to have the best-in-class technology partner to go down that route. makers, a gaming company, because visualization is these days about games, makers of Fortnite. So let me invite on stage Craig Barr from Epic Games, who will tell you all about that.
Thank you, Akash. Hello, welcome here today, guys. Thank you for coming. My name is Craig Barr. I'm from the Epic Games Enterprise team, where we're responsible for working with non-games industries to help rethink how real-time technology can solve real problems. So at Epic Games, we kind of work in this dual branch structure. So what is it that we do? Well, on the one side, we have the software development side, things like Unreal Engine. On the other side, we create games, we publish games. So with that, how many of you have heard of a little game called Fortnite? We've talked about that here this morning. Yeah, not so little, and of course created with Unreal Engine. The other side of what we do as well is we license Unreal Engine to other games and non-games customers. So in the enterprise team, we focus on 4 major industries here. So AEC, manufacturing and design, film and television, and training and simulation, all 4 of which have in common some really exciting developments in real-time technology. So just to give a little taste, we're going to take a look at a short video that demonstrates some of the capabilities of what is possible here in Unreal Engine.
I'm Siren, and I'm a digital human.
Some cool stuff indeed there. So the big takeaway from this, though, is that all of those sequences are rendered real time. So between 20 and 90 frames per second, even though they look like they're rendered with traditional offline rendering tools. So right now, we're sitting at about 10,000 times faster rendering with Unreal Engine compared to traditional offline rendering solutions. And of course, you're seeing the similar quality with that. So last year, what we did here is that we unveiled Unreal Studio. And with Unreal Studio, we targeted, or what we wanted to do is target directly to architects and designers. So this provides everything that architects need to be able to bring in data, regardless of how complex, into Unreal Engine. And most importantly to architectural firms, it's a free offering. So since then, we have over 270,000 registered users for Unreal Studio, and the majority are within the architectural space. So CG Architect recently did a survey of visualization experts, and we were the #1 real-time solution for rendering in the AEC space. So at this point, Unreal Engine has become the standard for visualization. So while Unreal Engine has won over the hearts and minds of the technical visualizers, our next step is to win over a lot of you guys right here, the architects and the designers. So to help do this, we recently acquired Twinmotion, and it has everything architects need. Some applause there, that's good to hear. So this has everything architects need, really simple interface and direct links to ARCHICAD and Revit. So what is Twinmotion? Well, really simply here, Twinmotion is a really powerful visualization tool for AEC professionals. It's very easy to use, and it's a great way to create very compelling, beautiful, stunning visualizations and presentations within minutes. So since we announced the free download, that's right, so Twinmotion you can grab right now for free. We have, it's actually, the number has substantially jumped since this here the other day, but we're well over 90,000 registered brand new users. So most importantly though, is that together with Graphisoft, we're working on the next gen version of Twinmotion. And this will allow us to bring projects right from Twinmotion into Unreal Engine for further development. So it'll also take advantage of the latest technologies and features from Unreal Engine. As an example, real-time ray tracing. So once again, I'm going to welcome Belinda to the stage, who will now demonstrate, using the latest version of Unreal Engine, why you should care about real-time ray tracing. Thank you.
Thank you, Craig. Yeah, so Craig just mentioned it, real-time ray tracing in real time, RT. It's been making headlines lately as the rendering method of the future, yeah, for games, animation, movies, and now also for architectural photorealistic images. All right, cool, but what exactly is this real-time ray tracing, yeah? And why is it the best method for photorealism? And why should you, as an architect, care? So, well, I'm gonna demonstrate to you live, literally live, how this real-time ray tracing works. And for this, I would like you to do me a favor. So right now, please look at me and forget for now who I am. Yeah, I'm not Belinda. I'm a spot of light. Yeah, I'm a light spot. And you, all of you together, are this big, massive, huge computer, okay? And you, as the computer, you would like to know how this light spot here is generated. Yeah, where is the light coming from that creates this light spot, right? Okay, so now, please imagine a straight line going from your eye, which is the camera in the 3D model. So a straight line directly from your camera eye directly towards this light spot. Okay? And now continue this very line back to its light source. Okay? So a direct line from your camera eye to the light spot and back to the light source. Congratulations, guys. This is exactly what happens with ray tracing, yeah? This is exactly what the computer does when it generates photorealistic images, because you were tracing back the rays of light that were coming from that light source and were bouncing off of me straight back into your camera eye. All right, just instead of hours and hours and hours of doing so with traditional rendering engines, let me show you how the computer can now trace the rays in real time with Epic's Unreal Engine technology. Okay, so yeah, here I am in my ARCHICAD model. This is a beautiful residential area in Oslo, designed by our client Delta Architects. And now let's imagine that I'm the architect, and I'm really, really proud of my building, and now I want to sell this baby to my client. Yeah, I want to impress my client. And I'm going to do so by using first the current version of Epic's Twinmotion. Okay, so here we are. Okay, let's bring this ARCHICAD model into Twinmotion by simply clicking on one button, the direct link. Okay, so the way it goes is that ARCHICAD is now synchronizing the ARCHICAD model with the Twinmotion model, and I think this is a pretty cool thing. It's a pretty smooth workflow because the point here is no more time wasted in having to, manually export, import, re-import whenever there are changes made in the model. Nope, it's right here, and now I can already embark on the journey of exploring my design. Yeah, I can reflect upon my design in real time. And for example, I, as an architect, realize maybe here I could make a design decision. I want to change the window, so we can go back into the source model and maybe take over the big window here. And maybe, let's not forget, bring our little friend here into the front because I think a pink llama is definitely going to sell my design better this way. So what do we do now? Re-import and re-export? Nope. We just simply click on this magic button here and have Twinmotion do the job for me automatically. Yeah, and here we go. The changes have been updated, and yeah, now it's looking good. Now it's looking really nice. So inside Twinmotion, so we have a really non-destructive export workflow. That's nice. What else? So we have a really simple interface. On the left, we have a menu with which you can, populate the scene, try out materials. With the menu on the bottom, you can interact with your scene. You can change the weather in one go, or and with the menu on the left, you have your layers and your hierarchies, and you can just organize your scene. Let me just turn on something, and since we are in sunny Vegas, let's bring this back on. Yeah, so you see, nice integration, really super cool, simple interface, and you can now start telling your story in real time. But what's not real time here is the ray tracing. You see, Twinmotion has a pretty good, decent image quality, yet it's still somewhat missing that edge to it that would give it tad more realism. Yeah, that would make it a bit more realistic. And why is that? Well, because it's not yet running on the latest Unreal Engine. So let me switch to the latest Unreal Engine to show you what Epic's future Twinmotion will be able to do. So here we go. This is a ray-traced rendering right out of the box. Yeah, no more hours and hours of pixel by pixel tracing back all the rays. Nope, this is straight from the Unreal Engine, and I'm ready to step inside my rendering and show you a little bit around. So you see that while I navigate, while I move, while I do things in my model, the computer is tracing back all the rays of light that are coming from all these multiple light sources in real time. Yeah, this is why it already looks so stunningly realistic. And yeah, this is pretty cutting edge. This is really cool. So now let's continue telling my story. And for this, I'm going to switch back to the Unreal Editor. And here you see that while I drag and drop objects, while I bring my scene to life, while I do things, modify things, edit things, I get immediate feedback while maintaining the highest image quality possible. So whether it's these trees here, or this, this beautiful, shimmering, glimmering, glowing facade, or this, the reflection in the glass railing, whatever it is, it's being calculated physically correct in real time. So basically, what you see here is what you get. Okay, now I want to continue telling my story. And I'm going to switch to the custom menu here. So I have this beautiful daylight scene, and now check this out. With just one move, just one slide, while ray tracing is activated, I can simply and quickly switch from the daylight scene to a beautiful romantic dusk shot or a night shot. Yeah, really nice, really beautiful. So you see the shadows are ray traced, the indirect shadows are ray traced, the reflections are now ray traced, translucency is ray traced. So maybe let me just show you quickly how it looks like if I just turn off ray tracing for indirect shadows. You see the impact it has on the human eye. You see the difference it makes if it's ray traced or not. You see, it's all about the details. It's about the little details in life that make the big differences. So that's why I'm going to go ahead and add some more details to my story. And I can just simply add some cool after the rain effect here on the wooden platform in the front. Or I can just add clouds to the sky, just for me to be able to check how my building would look like if it's subject to Seattle weather, maybe. So, and then I can also go ahead and play around with some materials here. I can make material design decisions on the go, without having to wave on the best image quality. So yeah, let's put it this way. I'm quite happy now with my rendering. And now I want to share this with my client. So what do? Guys, just quickly take a screenshot, and that's it. And send it off. Done. So why should you care about ray tracing and real-time ray tracing? Because obviously, psychologically, it does make a difference when it comes to selling your design. I know it depends on the situation, it depends on the client, but if you really want to have a convincingly immersive experience, then you want it to be as real as possible. And with Unreal and ARCHICAD combined as a killer combo, it's definitely going to be possible. Right, Akos?
Thank you, Belinda. Thank you, Craig. So we have timed the announcement of our strategic co-marketing agreement with Epic Games for this specific event. So in a couple of hours, our press release will be sent out to the global press. And you may wonder what's in it for you guys, ARCHICAD users. There's a special, part of our agreement, which is all qualifying ARCHICAD 23 customers will get free access to the next-gen solution from Unreal. So thank you, guys. So we have covered, I suppose, most of the possible areas of our world. Now, the last question open is timing. So with all these many things going on, our release plan for this year is in the fall season. To be more specific, ARCHICAD 23 will start shipping in September. Thank you very much. And let me leave you with a little movie that our marketing department created for us. Every once in a while, we take architectural classics and remodel them in ARCHICAD to show how modern BIM tools can cope with, challenging and very peculiar architectural design. So we have created a little teaser video about the work we have been working on. I would like to show that to you now, and thank you very much for listening to this presentation. Thank you.